Hi there. In this video, we're going to talk about the standard normal model, which is labeled Z, and we're going to talk about Z-scores and learn what they are and how to calculate them. Okay, so first of all, the standard normal model. We use this when we want to compare unlike events. So even if two events are quite different, we can still compare them using the standard deviation as a ruler. Let me draw just a little number line here, and I'm going to put 0 in the middle. This is, if something lands right on the mean, we're going to say that is right at 0. And then we're going to label 1, 2, 3 for 3 standard deviations to the right, and -1, -2, -3 for 3 standard deviations to the left. So we could say, so this 1 is like 1 standard deviation above the mean. I'm abbreviating here because there's not a lot of space. And -1 is 1 standard deviation below the mean. Okay, so think of this standard deviation, like we saw how we label 3 on each side. Think of the standard deviation as a ruler. And what we're going to be calculating is, for a certain event, how many standard deviations is it away from the mean? If it's positive, it's going to be above the mean. If it's negative, that tells us it's below the mean or below average. Okay, so we're back to our rainfall example. Hopefully you're not getting too tired of this one. Annual rainfall for Portland is 40 inches per year with a standard deviation of 8 inches. And now we want to compare that with wind in Chicago, the windy city. So let's compare annual rainfall in Portland with the wind speed in Chicago. Now this says that it has an average of 10 miles per hour with a standard deviation of 2 miles per hour. So suppose that one year in Portland, the annual rainfall was only 24 inches, and Chicago's average wind speed was 13 miles per hour. Which one of these events was more extraordinary? Okay, so think extraordinary is unusual. So we're going to be looking for which one is furthest from the mean. Okay, so we have this formula for a z-score. What we do is we take whatever value we're given and we subtract the mean. So that tells us how far away from the mean a particular value is. And then when we divide by the standard deviation, that tells us how many standard deviations away that is. Okay, so let me write that down here. The numerator is the distance away from the mean, and then when we divide, this dividing by sigma tells us how many standard deviations that distance is. Okay, so let's do this example, so make it even more clear and concrete. Okay, so z-score for 24 inches of rain in Portland. We take our x value first, which is 24, and we subtract our mean. So our mean is 40, and we divide by our standard deviation of 8, which we are very used to know those numbers by now. Okay, 24 minus 40. Now I need to hit enter before I divide or use parentheses. Divided by 8 is -2. Now the units on the z-score is standard deviations. So this is -2 standard deviations. Or I could say, let me move this up. I could say 24 inches of rainfall is 2 standard deviations below the mean. Okay, I wouldn't say -2 below because that's a double negative. The negative means below. Okay, now remember when we drew this out? we can actually see that 24 is exactly 2 standard deviations below. Pretty cool, huh? But not every z-score will be right on one of the even standard deviations. So let's do the wind speed for Chicago. That was 13 miles per hour. Our mean is 10. And our standard deviation is 2 miles per hour. 13 minus 10, so that's going to be 3 above this time. That's why the order of the subtraction is really important, because it tells you positive is above and negative is below. So 3 divided by 2 is 1.5 standard deviations. Okay, or we can say that 13 miles per hour is 1.5 standard deviations above the mean. So really what we're doing is we're comparing this year in wind to all the years of wind in Chicago versus this year in rain to all the years of rain in Portland. So we're comparing apples to oranges, but we're comparing all the apples with the apples and all the oranges with the oranges. And so if we look at, let's go ahead and draw out our standard normal model underneath here. When we draw, just like we're used to drawing our normal model, but the mean is always 0, because when we subtract the mean, that puts the mean at 0, and we go 1, 2, 3, 1, 2, 3, -1, -2, and -3. So the standard normal model, we use the letter Z to distinguish it. So we use X for any regular normal model, but the standard normal is used with Z, is denoted by Z. And that's always normal 0, 1. So the mean is always 0, the standard deviation is 1. You may have noticed when you go into GeoGebra that's the default. I don't know if it is, I think it is also for Online Statbook, it's the default, and that's because it's used pretty commonly with z-scores. Okay, so that is our Z, and then let's notice where Portland and Chicago were on here. So Chicago was 1.5. I'll put C for Chicago. And then Portland was at -2. So there's Portland. So which one was more unusual? And one was above average, one was below average, but Portland was actually further away from the mean, or more towards the tail. So the wind in Portland was more unusual or more extraordinary. Did I say wind in Portland? The rain in Portland was more extraordinary. Okay, so sometimes you'll be asked to calculate a z-score for a single value, and sometimes you'll be comparing two, just like we did here. Okay, now our next example